So here we're integrating some functions, and we need to know that if you integrate x to the n, then you add 1 to the power and you divide by the new power, but then you must remember to add c. Sometimes, well actually I prefer to just write it as 1 over n plus 1 x to the n plus 1 c, but both are absolutely fine. If you've got constants in there, then they just carry through in a similar way to differentiation. So for part A, we're going to add 1 to the power to make it x to the 4. We're going to divide by 4. I'm going to write it as a quarter. And then we do the same here. We will add 1 to the power for x. This becomes x squared. Divide by 2. It's going to become 3. And you can show an extra step of working if you like. Don't forget your plus c. Part B, part 1, finds this integral, slightly trickier integral, just because you have to do an extra step first, and there's going to be a negative power in there. So this is actually 4x to the minus 2 minus 1 that we're differentiating. But then it is the same again, so I'm going to write down here. So I'm going to add 1 to the power, it's going to become x to the minus 1. I'm going to divide by this new power, divide by minus 1, same as times it by minus 1, it's going to become minus 4. And then the minus 1 becomes x. Just, we need to basically know that if we differentiate x, we get 1. If we differentiate 7x, we get 7. You integrate the constant and you just put the x on the end. And again, we need a plus c in there, but that is our answer to this question here. So now in part 2, we've got a diagram of this curve, and it's asking, it says the curve crosses the x-axis at 2, 0, so it's given us the root of the equation. And then we've got a shaded area bounded by 1 and 5, essentially x equals 1, x equals 5, calculate the area of the shaded region. Okay. This bit here in blue is going to be a positive area, whereas this bit here in green is going to be, it's a positive area, but when we do the integration, it's going to give us a negative answer. So we need to be, that's what this question is testing, so we need to be aware of that. So this first blue area is going to be the integral between 1 and 2 of 4x to the minus 2 minus 1 dx. And I've already done the integral here, so I can just substitute that in. It's going to be minus 4x to the minus 1 minus x. I don't need the plus c in there. I can put it in there, but it will just cancel out. And then I can substitute in. I think I'll do it fully. I mean, calculators can do this very quickly, but it is important to be able to put the numbers in and be able to sort of deal with this sort of integral. So I'm gonna go ahead and do it. So I'm going to do minus 4 divided by 2 is going to give me minus 2. Then I'm going to minus 2 again. Then I am going to minus the next integral, which is minus 4 divided by 1. So that's minus 4 minus 1. And that's going to give me minus 4 minus minus 5, so minus 4 plus 5, which is 1. So I found the blue area. Okay, the green one down here. Green one is going to be the same integral, but it's between 1 and 5. Notice I'm expecting to get a negative, which I'm then going to flip around to be positive. But I can't. This question is basically saying, oh, do you understand that below the axis you get negative answers? Because if you go between 1 and 5, you will not find the area. That's why we're having to split it up into these two parts. So for the second part, I'm just going to write it out. It's going to be the integral from 1 to 5, not 1 to 5, sorry, 2 to 5 of 4x to the minus 2 minus 1 dx. We've already integrated this before, so I'm just going to write it out. Okay, then I'm going to substitute these numbers in, try and do it without a calculator. You can do it with a calculator to be a bit quicker, but let's just do it anyway. So this can become minus 4 over 5 minus 5 minus, and then a bracket. It's really important to put these brackets in. Then minus 4 over 2, so that gives us minus 2. We've got the same thing that we had before here. Okay, I'm going to actually use my calculator for this bit. So then I'm going to get, that just gives, okay, I'm just going to substitute it all in. That gives me minus 9 over 5. So that is the green integral, and that means the area, total area, is going to be 1 from the blue integral, and then I've got minus 9 over 5, but the actual area is 9 over 5, so I'm going to add those, and that gives me 2 4/5, or 2.8 if I want to write it as a decimal. Often the answers, they like to leave them as fractions, but you know, both of these are exact, they're absolutely fine. So yeah, this bit's a bit harder because you have to remember about this negative bit. You've got a bit more number crunching going on, but that is the answer.